So force of friction notes. Please put your phones away, turn off the games. Now look at this. Force of friction, this is the most important thing with friction. It always opposes the motion. So if I pull the block to the right, the force of friction is to the left. Okay? If I'm falling from an airplane down, the force of friction goes up. Force of friction always opposes the motion of the object. And the ones that you're going to be working with in this class is typically sliding objects on surfaces. Okay? And it always will act parallel to the surface that's in contact. Okay? Now, this picture here, we typically don't draw our arrows like that, do we? We would pick this arrow up, put it on the other side, pick this arrow up and put it on this side. Yeah. But you can see how this works with that picture. Now, the magnitude of the force of friction is given by mu Fn, which we just discovered in that lab we just did. As mu gets larger, the force of friction will increase. So this is just like, think about like sandpaper. Yeah, it's rough, right? Or like brick. It doesn't feel good on your skin when you rub it. Versus like this floor is like shiny. The custodians wax this floor lots. It's very easy to slide on. So think about ice. Different materials are going to have different mu values. Okay? Now, the force normal, we talked about a little bit yesterday. But for a flat surface, the force normal is just mg for flat surfaces. We're going to stick with that for now. The force normal is just balancing the force of gravity. So force normal is just mg. We talked about this yesterday. That would be for cosine of 0. Cosine of 0 is 1. So this is just Fn equals mg. Do you want to put that note in to remind you? Let's do that. For flat surfaces, theta equals 0. Therefore, cos theta equals 1. And Ff equals mu Fn, which equals mu mg. That's a pretty important note for all flat surfaces. And you'll have a lot of questions involving flat surfaces. This is for the most part your focus. We will occasionally get objects on ramps. And when you have a ramp situation, you can't use this formula. You have to use this one here with cos theta. But for the most part, for flat surfaces, Ff equals mu Fn, which equals mu mg, because Fn equals Fg. Yep. Yeah, we're going to come back to that. Yeah. Yeah. And I'll just put, I guess, since Fn equals Fg. So you can replace Fn with mg. So as you're waiting for people to take down the notes, have a look at those last bullets. There's basically two types of the mu value. There's the static mu and the kinetic mu, which you should have discovered through the process of the lab. When you were pulling the spring scale, and then once the object started moving, what did you notice the spring scale did? It moves slightly back, right? It takes more force to get something going. Once it's going, it takes less force. Have you guys ever tried to move like a big piece of furniture or something? And it takes a lot just to get it going, and then once it's going, you can let off a bit. That's the same idea here. Now, like when you guys are doing calculations, like for the most part, you're just going to be finding mu k. the kinetic friction, like you're always probably going to be calculating mu k, and you can just call it mu. You will get, though, some like theoretical questions about the different types of mu. Now this is the picture that you need to look for. If you were to scan at a microscopic level of the interaction between like the block of wood and the floor, when you got really close, maybe with like an electron microscope or something, you would see that it's not perfectly flat. There's little bumps and valleys along the way. From our perspective, because we're so much, our eyes can only see so much, we see flat. But if you were like a microorganism down in there, there'd be these little, crevices, hills, and valleys that you would have to traverse. So that's what causes the friction. It's not like perfectly smooth. It's rough. Okay? Here's the mu k. Once you hit a certain threshold, it's easier to push, and the force of friction drops as you apply more and more force. So as you apply more and more force, the force of friction rises till a breaking point. That threshold is once it starts moving. Once it starts moving, and then it's a little bit easier. All right, a 5 kilogram block is sliding across a horizontal table with a coefficient of friction of 0.25. What's the force of friction? Force of friction equals mu Fn. That's from your data sheet. Frank, you don't have your book today? And Fn, if you looked at your free body diagram, what would Fn be the same as? In the free body diagram, what would Fn be the same as? Fg. So you can replace Fn with Fg. And Fg, if you recall from yesterday, has a formula of mg. So it's just mu mg. So it's 0.25 times 5 times 9.81. And to two significant digits, we have 12. 12 newtons. And that's essentially what you were doing today. Did any of you guys have about a 5 kilogram block? Not that heavy, right? How heavy was some of your guys' blocks? Or how much mass? You got about 5? Did anybody pull with 12 newtons? About 13 newtons? 15 newtons? And look at the coefficient of friction. It's pretty similar to what that group got, right? So here's just an idea of a number sense. It's nice to do the labs because then you have something to draw on from an experience point of view. Okay, a force of 14 newtons is needed to keep a 40 newton block moving at a constant velocity. That sentence is loaded with information. Loaded with information. A force of 14 newtons is needed to keep a 40 newton block. The first one I'm going to stop you is this one here. A 40 newton block. Usually we don't talk about blocks that way. We would say the block has a certain amount of kilograms, a certain amount of mass. So what did they just give me here? That's the Fg of the block. I don't have to do any 9.81 business. It's already been done. Now if it's moving at a constant velocity, the force applied has to be balanced. What's the force applied being balanced with? Force of friction. That was just like the lab. So this 14 newtons is what? What force? Which is the same as force of friction. So what is the coefficient of kinetic friction? Well, force of friction equals mu Fn, which equals mu Fg. So what do I got to do to solve for the coefficient of friction? Divide out the Divide out the force of gravity. So it's just the force of friction divided by the force of gravity. 14 divided by 40 to two significant digits, 0.35. The coefficient of friction has no units. Good observation, because what's happening in the numerator? Newton. What's happening in the denominator? Newton. Newton divided by Newton, they cancel. The coefficient of friction has no units. It's just a value. Yep. Okay with this slide? I'm just going to highlight this again one more time so you guys see it. This one here to this one here. Why is it okay to just interchange force normal with force gravity? Because they're equal and opposite on a flat surface. Horizontally flat surfaces, the normal is the gravitational. Equal and opposite. How many more questions we got? 2 more, 3 more, 4 more. Okay, so why don't you guys get a head start on this homework for tonight? Maybe start at 11, do a few, get a feel for it, and we'll continue this slide, this lesson tomorrow. You got lots of other homework to do as well? What? With the angles? We're not going to do that for a bit. Yeah. So please just get a head start on this. Maybe do like 11, 12, 13, 14.